Good morning, students. Welcome to the video lesson. Today we'll work out some of the problems on Pythagoras theorem. In the previous session, I have explained what is the Pythagoras theorem and what is the statement of it and how it is useful to our in our daily life. Everything I have explained in the previous sessions. Now let us see the problems which are involved with the Pythagoras theorem. This is a last exercise in similar triangles. I think with this we will complete the similar triangles chapter. So look at these diagrams. These are the this is, I think everyone know this. This is a ramp and this is a tent. So the height of a ramp, how to find out the height of a ramp and the length of a rope to put this tent. For this and all, we'll apply the Pythagoras theorem principle. So we'll apply this principle to find out some of the quantities in our daily life. See, the main problems I'll explain. I'll explain some of the very important problems in last exercise, and you may do the other problems easily. When you listen this video carefully, you understand it and you can do it the remaining problems very easily. Look at this problem now. ABC is a right angle triangle. The right angle is at B. The D and E are any points on AB and BC respectively. Prove that AE square plus CD square is equal to AC square plus DE square. So you have to read the question 1 to 2 times. So what is given here? It is a right angle triangle. What is this? This is a right angle triangle and the right angle is at B. So you have to locate the right angle at B at this point. So you have to show the right angle at B and DE are any points on AB and BC like this. And you have to prove that AE square, see this one, AE square plus CD square is equal to AC square, this one hypotenuse, AC square plus DE square, this one DE square. So when you closely observe this problem, what is there in the LHS? What is there? AE square is there, CD square is there. So where is AC, AE? Let us see. So this green line is nothing but AE and the blue line is nothing but CD. So we have to take the Pythagoras theorem statement in such a way that we should get AE and CD to represent it. So when you take this, when you look at this AE, so this one is nothing but the hypotenuse of this triangle ABC. So this AE is nothing but hypotenuse of triangle ABE, isn't it? Likewise, CD, when you look at this CD, this is nothing but the hypotenuse for BCD right angle triangle. So you have to write statements in such a way, like see here, I'll explain now. AE square. AE square is nothing but AB square plus BE square. AB square plus BE square. So the square on the hypotenuse is equal to the sum of the squares of other two sides. Again, when you take CD, when you take this triangle, BCD triangle, so you can write CD square as DB square plus BC square. So when you take these two equations as 1 and 2, when you add, so what is there you can see on LHS, you can see only AE square and CD square. We don't need AB or BE or DB or anything as such in the left hand side. So we need only AE square and CD square. So you have to group, you have to add these two like this. When LHS is added, so the right hand side will also be added like this. So And now you have to look at the right hand side. What is there in the right hand side? AC square is there, DE square is there. Let us see where is AC square in the diagram. So AC square is nothing but the hypotenuse of the big triangle, the red triangle, isn't it? So the hypotenuse, you can write this hypotenuse square as sum of the other two sides, that is AB square and BC square. So you have to group these four terms as two groups in such a way so that we can get AC square and DE square. So you have to group AB and BC at one group, and you have to group these two like BE and DB. So instead of AB square plus BC square, you can write AC square. Instead of this, you can write DE square. So very simple. It is very simple to solve. Just you have to look at LHS and RHS to solve this problem. One more problem. See, prove that 3 times of square of any side of equilateral triangle is equal to the 4 times the square on altitude. So when you take an equilateral triangle like this is an equilateral triangle. The square on any side of equilateral triangle. So this is an altitude. See, the height of the altitude is h and the side is A. This is an equilateral triangle. All the sides will be equal and the side is A units. So this one, when you look at this problem, see carefully. So you have to show here the square on the 3 times the square on side of the equilateral triangle. So you can take any side. So when you take BC side, 3 times the square, that is 3A square, should be equal to 4 times of square of altitude. What is the altitude here? It is h. Square means h square. 4 times of square of altitude means 4h square. So you have to prove that 3a square should be equal to 4h square. So for that you have to apply similarity of triangles in this problem. So you have to look for the congruent parts in these two triangles, the triangle ABD and the triangle ACD. In these two triangles, we have to look for the congruent parts. So when you look at this diagram, you can say that angle B will be equal to angle C. Why these two angles are equal? It is already given that in the question, this is an equilateral triangle. So this is an equilateral triangle means all angles will be equal and all angles will be equal to 60 degrees. So therefore angle B will be equal to angle C. And angle D will be 90 degrees. So this altitude is perpendicular to base. So by angle similarity, you can say that these two triangles are similar with each other. That is the triangle ABD and the triangle ACD. So when the triangles are similar with each other, you can say that the proportional sides may be the corresponding sides may be proportional or equal. So the BC is A, you can say that the D will divide the BC line segment into two equal parts. So you can say that the BD will be equal to CD. BD will be equal to CD. And so now when you take this triangle, ABD triangle, AB is nothing but the hypotenuse. So the AB square will be equal to BD square plus AD square. So AB is A. A square is equal to BD means half of BD is half of A. That is A by 2. A by 2 the whole square. And AD is nothing but the altitude, that is H. So when you square it, you will get A square by 4. This is H square. When you cross multiply, you will get A square plus 4H square. The denominator will be 4. And again, when you cross multiply, this 4 will come and place here. So the value will be 4A square, that is equal to A square plus 4H square. So when you bring this a square to the other side, you will get 3a square. So a square is subtracted from 4a square. You'll get 3a square, that is equal to 4h square. So you can say that 3 times of the square of BC is equal to the 4 times of the square of AD. So easily you can prove this problem. One more problem we'll see. See, this is the problem we'll see in our daily life. So I told you know how to we'll apply this Pythagoras theorem principle in our daily life. See, I'll show you how we'll apply this Pythagoras theorem principle in our daily life to find out some of the unknown values. See, when two poles are there, two poles of heights are given. One pole height is 6 centimeters, the other one is 11 centimeters. Stand on the plain ground. If the distance between the feet of the pole is also given, that is 12 centimeters, find out the distance between the poles. So we know the heights of the poles and we know the distance between the poles. But we don't know what will be the heights, what will be the distance between the tops of the poles. So I'll show you with the help of a diagram now. See, this one is a pole. This pole of height 11 centimeters. And one more pole is there. This pole height is 6 centimeters. And we know the distance between the poles is, how much it is? It is 12 centimeters. And we have to find out in this problem what we have to find out. And you know, the height of this yellow pole is 11 centimeters. The height of this green pole is 6 centimeters. So what will be this length? The height of CD will be, when you subtract BAB from CE, you will get CD, isn't it? Therefore, 11 minus 6, you will get 5 centimeters here. So what you have to find out? This one, the distance between the poles, that is CB, you have to find out. So when you closely observe this diagram, you can see one right angle triangle formed here. So in this right angle triangle, you know the base and you know the height also, but you don't know what is the hypotenuse. So now you can apply the Pythagoras theorem principle to find out the hypotenuse. Here the hypotenuse is nothing but the distance between the tops of the poles, the distance between the tops of the poles. Let us work out the problem now. What is given? The height of the yellow pole is given, that is CE, that 11 centimeters. And the green pole is AB, that is 6 centimeters. Distance between the poles is also given. How much it is? 12 centimeters. The difference between the heights of the poles is also given. How much it is? It is 5 centimeters. And we'll apply the Pythagoras theorem statement, that principle here. So BC square is equal to BD square plus CD square. BC square, that is the hypotenuse square, is equal to the sum of the other two sides, the square of the sum of the other two sides, that is BD square plus CD square. So when you substitute 12 here, you know the BD is 12 and CD is 5. 12 square is nothing but 144. 5 square is nothing but 25. When you add, you will get 169. When you take the square to other side, it will become root. The root for 169 is nothing but 13 centimeters. So very easily you can find out the distance between the tops of the poles. So very easy problem. One more problem we'll see. See this one, prove the area of an equilateral triangle described on the side of the square is half of the area of the equilateral triangle described on its diagonal. See, I highlighted some of the sentences here. See, look at this. So we have to take the side of a square. So in this diagram, we have to take the side of a square. So this is nothing but a square. And this is a diagonal of the square. So the area of equilateral triangle described on side of the square. So when you take any side, these are the vertices. You know the square length will be A units and the diagonal. So in a square, if we know the side of a square, you can easily find out the length of a diagonal, isn't it? The length of a diagonal will be root 2 of side. The square side is A centimeters. The diagonal length will be root 2A. So this one is root 2A. And when you take a equilateral triangle, see, look at this. This is DBE. DBE is nothing but a equilateral triangle which is described on the equilateral triangle which is described on the diagonal of the square. See, the area of an equilateral triangle described on the diagonal. So this one, and the area of a triangle. See, one more triangle you have to take. That triangle should be on lie on the side of a square. So the red triangle is lying on the diagonal. The green triangle lie on the side. So what you have to prove here, this area, this green color shaded area will be half of that of this triangle, this one. So let us solve this problem now. Let us solve this problem now. So for what we have taken first, the square, that is ABCD is taken. We have taken AB value as A units and BD value. We found out that BD is nothing but a diagonal of the square. It will be equal to root 2A. It will be equal to root 2A. The area of an equilateral triangle, this is the formula. So when the side of a equilateral triangle is given, you can find out the area of an equilateral triangle will be equal to root 3 by 4A square. What will be the height of an equilateral triangle when side is given? You find out. You find out and you may post in the comment box. So root 3 by 4 A square is equal to the area of an equilateral triangle. The area of an equilateral triangle BCF is given. BCF. So this one, the side is nothing but A. See, look at this BCF triangle carefully. This triangle based on the side of a square. So BC is nothing but a side of a square. You know what is the side of a square? It is A. So the area will be root 3 by 4 A square. And the area of a triangle BDE, when you take the big triangle, that is red triangle. So what is the base of this red triangle? The base of the red triangle is nothing but a diagonal. So how much the diagonal it is? It is root 2A. So the same formula will apply here. In place of A, you can write root 2A because the base here is root 2A. So this one, when you simplify it, root 2 the whole square, A square, root 2 the whole square, when you cancel it, the root and square will cancel out and you get the 2, and you group this in such a way that you get this formula, that is root 3 by 4 A square. So you can move this 2 to other side and you bring A square to this side. So this is nothing but root 3 by 4 A square. You group in this way. So in place of this root 3 by 4 A square, you just simply, you can substitute the area of a triangle BCF. Why? Because you know that the area of a triangle BCF is nothing but root 3 by 4 A square, isn't it? So the same thing you can substitute here. So in place of this, I have substituted area of a triangle BCF, then the into 2, when you bring this 2 to the other side, so naturally, this is half of area of BDE. So the big triangle, the red shaded area of a triangle is this area of a triangle, half of this big triangle, half of this big triangle, the half of this red shaded area of a triangle. When you make it half, you'll get this small triangle. So this green shaded triangle will be half of this big triangle. So the red area triangle, equilateral triangle, if it is 100, and this green triangle will be 50. So this one you can apply anywhere, and you may get these problems in further in future in competitive exams also. This, they may link this concept to solve some of the problems. So the concepts of similar triangles is very important, and you students, you feel more tough when you listen the word similar triangles. And I think when you listen the video lesson carefully, your all doubts will be rectified. And when you solve the problems, you can do it. And this is the last session of this similar triangles. I think each and every student has understood. All the best, solve better, and make use of these videos to solve the problems. Thank you.